Hello friends, coming to the next second video for electronic devices and circuit. In first lecture we discussed the importance of electronic circuit devices and circuit for the gate exam, how much marks comes from electronic EDC subject in gate, and importance of the subject and analysis, paper analysis of the subject for this, and syllabus, and some part also continue in what is in the extrinsic and intrinsic semiconductor material, insulator, conductors, and semiconductor material. These points covers in last lecture. Now in this lecture we continue the PN junction diode. In PN junction diode, two materials are used, that is p-type and n-type semiconductor materials are combined together and form a junction, that is p and n junction diode is formed. If we use separately p-type material or n-type material semiconductor material separately, there is very less uses of that material, very limited uses of p-type and n-type semiconductor material. If we combine two material, that is p-type and n-type semiconductor, then it's act as a very famous example like diode or other transistor also, MOSFET also. This the semiconductor devices which is used for each two semiconductor combined. If we join two pieces of p-type material and n-type of semiconductor material such that the crystal structure remains continue, the boundary of the p-n junction diode is formed. If we form two material, then it can function as a rectifier also, rectifier, amplifier, switch also, and other application of electronic device operation, other operation also in electronic devices. If a PN junction cannot be produced by simple pushing two pieces of metal together or by welding, this cannot be possible because it gives rise the discontinuity across the crystal structure. If we do like this, then this cannot be apply or cannot be act as a conductor. This only crystal structure only combines. It is not possible for that because the depletion layer and some special fabrication techniques are adapted for PN junction diode formation, for that like this properly. So the question comes in your mind, what is mean by PN junction? P and N junction. PN junction is a device formed by joining p-type material with n-type material, that is arsenide, gallium arsenide, and other semiconductor separated by a thin junction. Separated by a thin junction is called PN junction diode or junction diode. It is also called a junction diode. But in PN junction diode, if we use the gallium arsenide or silicon material, it depends upon manufacturer. It totally depends upon manufacturer. These are the symbol of PN junction diode: p-type material and n-type material. This is the deflection layer. These are the deflection layer. These are the deflection layer. This is a p-type and this is the n-type and this is p-type material. This is the anode cathode terminal and this is the anode terminal of diode. This is the anode and this is the cathode terminal of diode. Okay, if we apply here in p-type material, holes are present and here electrons are present in n-type material. It's a majority carrier, it's holes majority carrier, and here electrons is majority carrier. So in P and N junction diode, if we apply the voltage for this terminal like this, then it acts as a diode or conductive material, because if we apply here the plus volt, it moves from here and electron move for here, and this recombine from this, and current will be flow like this. Current are flow like this. It acts as a diode. If we combine, if we connect the negative terminal here and positive terminal here, then it's replication of electrons and holes like this. Then it act as a open switch. The diode is in reverse bias. This cannot be work. It's a positive, or it's a switch. It is a open switch, like current cannot be flow. These are the property of semiconductor material. Okay, in in this slide, uh, in PN junction diode, P is a right and N is in right side and P is in left side of majority. In P region, the majority carrier is holes, and N region is a majority carrier is electrons. I already told you, if the current is provided, some charge is provided to electron, then electrons move from N region to P region. It's the mobility is carried out, and charge is flow. Current is flow from this to this. These are the I already told you, if the diode is in forward bias, then it acts as a closed switch. If the p-type material is connected to positive terminal of battery, and n-type of means cathode terminal is connected to negative terminal of the battery, then the diode is in forward bias. But condition is that the voltage of the battery is more than cutoff voltage. Your question comes in your mind, what is meant by cutoff voltage, and how much cutoff voltage is required to act as a diode act as a conduction stage? It is totally depends upon the material of semiconductor, which material are used. Suppose, for example, if the manufacturer use a gallium arsenide material for manufacturing the diode, then cutoff voltage is 0.3 volt. What is meant by cutoff voltage? The cutoff voltage is that the diode or material, the electrons move from one state to another state. Minimum voltage is required to move the electrons from one state to another state. That is the cutoff voltage. If the 0.3 volt is gallium arsenide, then less than 0.3 volt, the diode or the electron cannot be moved. This is the cutoff voltage of gallium arsenide. If use the silicon material is used, then 0.7 volt is a cutoff voltage of that diode of that devices. Understand that what is meant by cutoff voltage and material depends upon that manufacturer. These are, if comes to the point, if the diode is cathode terminal is connected to positive terminal of the battery and anode terminal is connected to negative terminal of battery, then diode is in forward bias, then current flow, and it acts as a closed switch. exactly reverse. If the anode terminal is connected to negative terminal of the battery and diode is connected to cathode is connected to positive terminal of the battery, then diode it is in reverse bias and it acts as a open switch. Then the question is for formation of depletion layer. How to form the depletion layer? If we combine two materials, p-type and n-type semiconductor is formed combined, in between the p-type and the n-type is the some band gap is there, that is a deflection layer. If the excess of electron region is cross the junction and combine with the excess of holes region, then no external connection at that time, the depletion layer is formed, that is the band gap. In that, the n region loses its electron, become a positively charged, and p region is accept the electrons because it's negatively charged. At one point, the migratory action is stopped. Suppose, for example, in p-type material, 5 holes are present and n region 6 electrons are present in the majority carrier. If they recombine 5 holes with 5 electrons, but 1 electron is remaining, it's move everywhere, but it cannot be, no one is acceptor for that electron. That's why they act as a positively, the reason is losses its electron, become a positively charged. And p-type, if the vice versa, if the holes are 6 and electrons are 5, then it's recombined 5 electrons with 5 holes, but 1 hole is remaining. And then p region accept the electrons because it is a negatively charged. Okay, so at this is my stop, the action is stopped. And in addition of electron, p regions are n regions are replicated by the net negative charge, electrons as is the negative charge and holes are as a positive charge. That's the reason is replicated as the negative charge of the p region. Similarly, addition of holes from p region are replicated by the positive charge of the n region and net charge of the region. Creation of thin layer of each side of junction with the depleted emitted from the diode mobile charge carrier. This is known as the depletion layer. Suppose the creation of thin layer of each side of the diode, which is depend upon the mobility of charge, means the mobility of charge carrier. If the diode is remaining for that, then it is the deflection region is formed, is known as the deflection region. The thickness of the order of 10 to the power 6 meter, deflection layer thickness is the order 10 to the power 6. Thus the PN junction diode allows the electron flow only when P is positive charge. The junction diode allows the electron flow. I already told you, if the cathode terminal is connected to negative terminal of the battery and anode terminal is connected to positive terminal of the battery, then the electron flow only. If the otherwise the electron cannot be flow. This property is used for conversion, means rectification of AC into DC. This process is known as rectification process. The conversion of AC into DC is called as the rectification process, and this process is done only by using diode. Diode is a semiconductor material. It acts as a switch. The deflection layer contains no free and mobile charge carrier, but only fix the immobility ion. The width depends on the doping level. The depletion layer width is depends upon the doping level of that material, semiconductor material. The doping, if heavily doped, then thin depletion layer is formed. If lightly doped, then thick depletion layer is formed. Same concept is here. Apply on potential barrier. If the thin and thick, if the thin depletion layer recombines, the potential barrier is more. To reach the electron N terminal to P terminal, they have more energy. They require more energy to reach there, because the barrier or the band gap of the holes and electron is more, means thick. So that's why they can apply more energy or power to recombine them. For this, the electron try to cross from the N region to P region, express the restarting field, the battery, and therefore replied similar the holes from P region. Same current is concept is applied on P region also. If the potential barrier is less, if the band they require very less power for that. If I already told what is the cutoff voltage and cutoff voltage for germanium and silicon. Here is see here is the cutoff voltage is here for germanium and silicon. These are the silicons and these are the germanium. The potential barrier. The potential this is produced are called potential barrier. Okay, good. So you getting you now we go for next slide. These are the diagram of P region and N region terminal connected to battery. P type is doped region, P type is doped, and N type. If the current is here, the current is connected to positive. P type terminal is connected to positive terminal, and N type is connected to negative terminal of the battery. And same concept for this. If the connection is reverse bias, then diode acts as an open switch, or it is in reverse bias. The polarity of the material is same. Next slide. The PN junction can be basically work into two mode. A battery is connected to the diode, forward bias and reverse bias. The positive terminal is connected to P region and negative terminal is connected to N region. I already told you in the block diagram. Then the diode is act as a forward bias mode, and vice versa. If the positive terminal of the or cathode anode terminal is connected to negative terminal of the battery and cathode terminal is connected to positive terminal of the battery, then the diode act as a reverse bias. These are the functions. The forward bias PN junction, it forces the majority charge carrier to move across the junction by decreasing the width of depletion layer. If the positive terminal is connected to P-type material and N-type material is connected to negative terminal of the battery, then the depletion layer is decrease the junction, the width of the depletion layer is decreased, and then it is act as negligible and it flow the current. Once the junction is crossed, the number of electrons and holes are recombined. For each holes in the P section that combines with the electrons from the N section, and covalent bond break, and the electron is liberated, which they enter the in positive terminal. Then covalence band is break. At that time, the crowd of that depletion layer is very much in P side is the hole and inside is the electron. Then it as the recombination combine. It's the law of energy attraction like this same, then at that time the bonding of covalent bond is break and that is recombined, and this is one type of, is the material is one type of conduction material, this creating an electron hole pair. The current in p region is carried by electron, and current in n region is carried by electron, and current is p region is carried by holes only. These are the function of that. A reverse bias p-n junction there, if the positive terminal of the battery, I already told you, if the positive terminal of the battery is connected to the p type n type material, and negative terminal of the connector is the free electron and free holes are attracted back towards the battery. They attracted the battery terminal, and hence the back from this the depletion layer of the width of the depletion layer is increased, so the material act as a insulator. These are the property of the semiconductor material. Thus the reverse bias p-n junction does not conduct the current. That's why the width of the deflection layer is more, so that's why the current cannot be flow, and it acts as an open switch. Are getting concepts? Only the majority carriers cross the junction considering the very low reverse saturation current. At that time, very means negligible, the current is flow, that is a reverse saturation current. This current is of the order of microampere, and तो microampere मध्ये असतो. The voltage current VI characteristics of semiconductor PN junction diode is shown in here.